Thank you. pessoal, nós já estamos aqui. Boa tarde, pessoal. Já estamos aqui ao vivo, direto da Cap Kennedy, tá? Cap Canaveral. E
The team of flight controllers in Mission Control Houston today is being led by Flight Director Rebecca Wingfield. The teams here in Mission Control will really jump into action tomorrow night into Saturday morning as Cargo Dragon approaches the International Space Station and enters the approach ellipsoid, which we like to think of as an imaginary sphere around the space station that helps us monitor the approach and departure of visiting vehicles. There are currently 7 crew members living and working aboard the International Space Station. Expedition 65 consists of NASA astronauts Shane Kimbrough, Megan MacArthur, and Mark Van High, whereas cosmonauts Peter Dubov and Oleg Novitsky. Aki Hoshide of JAXA and Tomas Pasquet of the European Space Agency.
Mas ele vai lançar e pousar novamente para ser reutilizado. Então, essa nave é uma nave de carga levando suprimento para a Estação Espacial. Tá? É uma nave toda nova, tanto o booster como a Crew Dragon,
This will be the first of 3 deliveries of these
suprimentos. Então, é uma nave inteiramente nova, nunca foi reutilizada. Vamos aí acompanhando, vou deixar vocês com as imagens e com o áudio em inglês. Estou deixando com legenda, porque para algumas pessoas são mais fáceis de entender. A gente vai interagindo aqui, trocando ideia. Abraço, obrigado a todo mundo que está na live.
Crew Dragon, Cygnus 15, the Soyuz MS-18, and Progress 77. Cargo Dragon will remain attached to the International Space Station for about 1 month before being packed up with critical science and supplies and will splash down in the Atlantic Ocean for that science to be analyzed back here on Earth. Again, everything is still a go from here in Mission Control Houston, and we're looking forward to welcoming another vehicle to the International Space Station. So for now, we'll head back out to Kennedy. Megan.
It is now T-minus 8 minutes and counting until liftoff of the Falcon 9 rocket and Cargo Dragon on the next resupply mission to the International Space Station. Now, you heard Courtney just mention the new solar arrays again. So let's take some time to go more in depth about those because they're really important to the station and what happens there. Take a look at your screen now. This is the first pair of the new Boeing-made ISS rollout solar arrays known as IROSA. They are made up of compact panels you see there that roll open like a huge yoga mat, 63 by 20 feet each. Here they are inside the Space Station Processing Facility at the Kennedy Space Center before being packed inside Dragon. The space station currently has 8 pairs of solar arrays. The oldest pair has been in use for more than 20 years. The 2 new solar arrays, plus 4 more to be delivered later, will produce a total of more than 120 kilowatts of electricity. That is enough to power more than 40 U.S. homes. Once combined with the 8 original arrays, the new ones will boost power to the station up to 30%, maximizing use for the orbiting lab for many years to come. And these two new solar arrays, like Courtney said, are going to be installed this summer. Now let's head back over to Shiva for an update. Shiva?
Thanks, Megan. We're just over T-minus 7 minutes to go. The SpaceX team currently working no significant issues with the vehicles. At this point, Rocket Propellant 1 fuel is nearly fully loaded on the first stage, completely loaded on the second stage. Liquid oxygen loading is underway on both of the stages as well, and that'll complete at about T-minus 2 minutes to launch. We're also loading helium gas into both of the stages. Falcon 9 uses helium as a pressurant, that's to backfill propellant tanks as we consume liquid oxygen in RP1 by the Merlin engines during ascent. The helium loading began before the webcast went live, and we'll continue to top it off until about 1.5 minutes before launch. Now, to make sure that the engine startup goes well, we also perform what's called engine chill. It started at about T-minus 7 minutes. We flow a small amount of that super chilled liquid oxygen into the Merlin engine turbopumps, and we do that to avoid thermal shock to the mechanical components once we get that full flow of super chilled liquid oxygen on engine start. Dragon also began its startup sequence at T-minus 35 minutes when it coordinated timing with the Falcon 9. It's currently undergoing a set of vehicle health checks, with its next major milestone happening just before liftoff when it'll transition to internal battery power. The range is standing by, ready to support today's mission. Launch weather is continuing to trend favorably. We had a 60% chance of go, and we're still continuing to monitor some of those clouds and precipitation in the area. So with that, the launch team, Falcon 9, Dragon, the range, all looking good. Weather also trending good. And at about T-minus 5 minutes to go, I'm now joined by Marie to help me walk through these final moments of the terminal count. Marie?
Yeah, Shiva, as you said, weather trending in the better direction. It was a little bit hairy for a couple minutes there. Within the last, I want to say maybe 13 minutes or so, it was right around T-minus 19 or 18 minutes. We heard about some lightning strikes in the area, not coming within that 10-mile radius of the pad, but that was a watch item. It looks like they're not expecting lightning to be an issue to come that close. And that cell that I mentioned to the south of the pad looks like
Dragon has transitioned to configure for terminal count.
Between that area, not coming within a little bit more separation.
Dragon has transitioned to terminal count and is on internal power.
Okay, so we heard that call that Dragon is now on internal power. Again, as Shiva mentioned, the team has already conducted its pre-launch engine chill. Again, this is when SpaceX injects a small amount of super chilled liquid oxygen to prepare those Merlin engines inside the first stage to allow for full propellant flow during flight. And we can hear the hissing from some of that liquid oxygen venting off the side of the rocket as it meets that
strong back retract in progress.
We just heard the call out there as well for strong back retract. The strong back is the truss structure next to Falcon 9 that provides propellants and power to the vehicle. So you can see the clamp arms are opening around the second stage, and the strong back will retract a couple of degrees away from the vertical position, helping to clear the way for Falcon 9's ascent. In these last few minutes, Falcon 9 is performing a set of health checks on its primary communications, avionics, and propulsion systems in preparation for flight. We'll continue to hear call-outs that the engines are sufficiently chilled in and for some of these milestones that are coming up next. And there you can see the strong back starting its retraction away from the vertical position.
And so we saw that strong back or transport erector retract ever so slightly from the Falcon 9 rocket. It will retract fully.
Bleed verification.
Just as we get to the moment of liftoff to allow for Falcon 9 to clear the pad. Also happening now are some checks of the second stage thrust vector control actuators. That is often referred to as an engine wiggle test, and this is when SpaceX moves the thrust nozzles. And we just heard the call for the stage 1 LOX load complete. Again, that engine wiggle test happening now to make sure that the guidance hardware is go for flight. SpaceX will do the exact same checkouts on the first stage engines, and that will happen just a few seconds before ignition.
Yeah, and we just heard that call out for first stage LOX load complete. Next major activity here will be second stage LOX load complete. Usually happens around the T-minus 2 minute mark, and that wraps up propellant loading for Falcon 9 until liftoff. Dragon also continuing to perform final health checks
Stage
to make
2
sure
LOX
all
load
of
complete.
its systems are ready to go for
Dragon is in
ascent
auto
and
idle.
rendezvous with the International Space Station. Weather continuing to trend favorably as Dragon transitions into its ascent state.
Weather remaining go as we are approaching the T-minus 1 minute mark when Dragon will transition to internal power.
Falcon 9's in startup. Dragon is in countdown. LD, go for launch.
Launch director pulled
Stage
go
2,
for
press
launch.
flight.
So with that, all systems are currently go. We're just over T-minus 30 seconds to liftoff.
T-minus 30 seconds.
And at T0, the rocket will be released from the hold-down clamps at the pad. And as I mentioned earlier, that strong back right next to the rocket will retract the rest of the way,
Já estamos
clearing
aí,
the way
pessoal.
for liftoff.
Menos de minuto do lançamento. Acompanha a qualquer momento.
Falcon 9
Já
is
vamos
configured for flight.
decolar. Atenção.
10, 9, 8, 7,
Contagem regressiva.
5, 4, 3, 2, 1, 0. Ignition. Liftoff.
And liftoff of the
Atenção,
22nd
lá
SpaceX
vai,
cargo
lá
resupply
vai.
mission, bringing
Decolando.
new arrays to the International
Decolando
Space Station.
a missão CRS-22 da SpaceX.
Stage 1
Vamos acompanhar aí, por enquanto tudo beleza, 100%. Empuxo bacana aí, vamos embora. Vamos rumo à Estação Espacial, moçada.
We're at T-plus 40 seconds into flight. Awesome shot looking
Power
back
and telemetry
at
nominal.
the Cape, where Falcon 9 has launched. We're coming up on the next major milestone. That's the point of maximum aerodynamic pressure. That's when the
Falcon 9 is
stresses on the
supersonic.
vehicle will be the highest.
Execute.
So in preparation for maximum aerodynamic pressure, we throttled down those Merlin 1D engines. Now that we're through that point, we'll throttle back up and continue on to the next of our sequence of events. We have several happening in rapid succession. That'll be main engine cutoff, followed by a stage separation. Then we'll have a first stage flip maneuver, second engine start, number 1, and then a boost back burn on the first stage. Now, main engine cutoff, or MECO, that's where all 9 of the Merlin 1D engines on the first stage will shut down. That's followed shortly after by stage separation, when both the first and second stages will separate. From there, the first stage will flip to prepare itself for entry. A few seconds later, the Merlin vacuum engine on the second stage will ignite to boost the Dragon into a low Earth orbit. That's called SES-1. And then finally, on the first stage, we'll have boost back burn start to slow down the first stage in preparation for re-entry. So again, those 5 events: MECO, stage separation, first stage flip maneuver, second engine start, and then the boost back burn, all coming up just in under 10 seconds from now.
And MECO.
Stage separation confirmed.
MVAC ignition.
Stage 1 boost back startup.
So successful Merlin vacuum engine startup. First stage has begun its boost back burn. That burn expected to last about 30 or so seconds. Here's a shot of the second stage Merlin vacuum nozzle. You can see it starting to heat up as we begin this burn. The second stage will continue to burn here for several minutes until about the T+8 minute mark.
Stage 1 boost back shutdown.
If you're just joining us, welcome. You're watching a live webcast for the 22nd commercial resupply mission to the International Space Station for NASA. This is SpaceX's 17th launch of the year, and we are flying a cargo configuration of our New Dragon spacecraft. On the right-hand side of your screen is the second stage, which is
Já vamos
carrying
observar em
the
instantes aí
Dragon
o
spacecraft
booster
into
pousando,
orbit.
né? A recuperação
On the
do
left-hand
booster.
side of your
Tá?
screen, you can see
Instantes, tá bom?
Falcon 9's first stage with the grid fins extending. It just completed its boost back burn and is making its way back to our drone ship. Now, the rocket has to do more than just go up. It has to go sideways really fast. At liftoff, gravity is pulling straight down on the rocket, but as we ascend, we tilt the engines, that's called gimbaling, and that begins to turn the rocket horizontally. We're still going up, but we're also heading horizontally away from the launch pad. That maneuver is called a gravity turn. The rocket typically needs to go about 7.5 kilometers per second, or about 17,500 miles an hour, to avoid being pulled back down to Earth and to get into orbit. So that's what the second stage is doing right now.
Daqui a pouquinho a gente vai ver o primeiro estágio chegando e pousando na balsa, tá?
It has 2 more burns to do. First is an entry burn. It'll ignite 3 of its Merlin 1 engines. That'll help to slow it down as it re-enters the Earth's atmosphere. And then the next activity will happen much closer to the drone ship. That is the landing burn. Will ignite just the single center Merlin engine to bring the vehicle's speed rapidly down to 0. You can see the grid fins that are extended on the left-hand side of your screen. We use those for atmospheric control. They help steer the Falcon 9 to make sure we make our way back to that drone ship as we get into the thicker parts of the Earth's atmosphere. And you'll occasionally see periodic bursts of a white gas like that. That's our attitude control system giving us little corrections to our attitude. So next major event coming up here for the first stage is entry burn. 3 of the Merlin 1D engines will ignite. Second stage burn continuing to look nominal. Second stage has a little ways to go. It won't be done with this burn until about the T+8 minute mark.
Stage 1 FTS is saved. Trajectory nominal. Stage 1 entry burn startup.
So with that, 3 Merlin 1D engines on the first stage igniting to reduce the vehicle's velocity. You can see that on the bottom left corner of your screen. This burn expected to last about 20 seconds. So from here, the grid fins will continue to take the first stage towards our drone ship stationed out in the Atlantic Ocean. At this point, T+6.5 minutes into flight, second stage is making its way to the initial orbit to drop off the
Vocês
cargo
podem
Dragon
observar
spacecraft.
aqui na tela, aqui, ó, do lado esquerdo a gente tem as velocidades aí, ó. Você vê que a velocidade do lado esquerdo ela está caindo, quer dizer, já está desacelerando o booster, que é o primeiro estágio, retornando para a Terra.
Nominal ascent so far. Talking a little bit more about the first stage. So the next major event coming up is that landing burn. Landing burn is what will bring the vehicle speed rapidly down to 0. Amazing shots of the first stage during re-entry. Once we get closer to the drone ship, we will deploy our 4 symmetric landing legs around the base of the first stage for hopefully a nice soft touchdown on that drone ship. You can see a shot of that on the right-hand side of your screen.
Stage 1 landing leg deploy.
Picture perfect landing of that Falcon 9 for the first stage. First landing for this first stage. 86 successful recovery overall for SpaceX. Fantastic. Coming up shortly, second stage is not done. It will be coming up on second engine cutoff. About under 30 seconds from now. It's been burning that whole time since stage separation to bring the 7,000 pounds of cargo into the initial orbit around our planet. And you can see we're getting close to orbital velocity.
Expected loss of signal.
Shutdown of the second stage engine. From here, we'll be looking at telemetry, make sure we are in the intended orbit.
nominal orbit insertion.
Fantastic. So with that, the second stage has just one major task left. It is commanding separation of the Dragon spacecraft just a few minutes from now. Until separation, the second stage will be making some small adjustments during this coast prior to Dragon separation. And we're hoping to have video, there's some video, into the unpressurized cargo section of Dragon. This video from the top of the second stage. We got a good look there at the new rollout solar arrays that Cargo Dragon is bringing to the International Space Station. So separation of the Dragon spacecraft expected at about T+12 minutes. We have a little bit of a coast here for ground operators in mission control behind me to ensure that the vehicle is in the right configuration, that there's no conditions that we may want to watch out for after separation. But Dragon and the Stage 2 right now in orbit. And coming up after that separation event, which hopefully we'll get a view like this of Dragon gently floating away, the Dragon spacecraft will begin to perform some of its own checkouts. Dragon is equipped with 12 service section Draco thrusters that are used primarily for attitude control and proximity next to the space station. It's also got 4 Draco thrusters on the top of the vehicle underneath its nose cone that we use for our thrust maneuvers to help us rendezvous with the International Space Station. So again, successful ascent, successful recovery of our first stage just a few minutes ago. You're looking at a live shot into the Cargo Dragon unpressurized section from the second stage that is in orbit around our planet. Our next major activity coming up shortly, that is Dragon separation from Falcon 9's second stage. Something a little bit different about this Dragon spacecraft. If you followed our first version of Dragon, you'd know that it had deployable solar arrays. This version of Dragon has conformal solar arrays on the body of the spacecraft. So those are mounted along the exterior panel of the trunk that we're looking into right now. Those provide power for the spacecraft as it makes its way to the space station.
Dragon separation confirmed.
Lovely. Planet Earth on the left-hand side. Dragon floating away. You can see
Isso aí, pessoal. Foi liberado aí agora
solar
a
arrays.
tá? A nave de carga
From
foi
this
liberado,
view,
já foi liberado
atop
o segundo
Falcon
estágio.
9 second stage,
E
watching
aí nós
Dragon
estamos
gently float
acompanhando
away.
aí, já tomando a direção
So
e o
again,
rumo dela para
activities
chegar na
coming up for
Estação
Dragon.
Espacial.
It will begin its service section Draco checkouts, followed shortly after that by
Dragon
the
separation.
nose cone
Expected loss of signal.
opening. And that's going to complete my coverage here from Hawthorne. But why don't we check in with Courtney at the Johnson Space Center in Houston. Courtney?
Thanks, Shiva. Again, just standing by for that nose clone deploy. The nose cone deploy uncovers the 4 forward bulkhead thrusters, which Dragon will use for its major burn maneuvers coming up. And nose cone hooks are driving now. And the hooks are halfway open, again standing by for them to be fully open. Again, standing by for nose cone deploy. That nose cone will stay open in the position until the very end of the mission.
É isso aí, pessoal. Então agora já foi o lançamento, já terminamos aí a parte do lançamento. No dia 5 próximo, tá? Dia 5, sexta-feira, não é isso? Hoje, aliás, sábado, às 5 horas da manhã é a previsão de chegada dessa nave na Estação Espacial Internacional. Para quem não estudou o que está acontecendo, com que carga que é, o que ela está levando, né? Essa nave ela está levando suprimentos, tá? Para os astronautas que estão lá, comida, esse tipo de coisa. Está levando alguns experimentos científicos, está levando painéis solares para serem colocados na ISS para compor a geração de energia, e ela depois vai descer, né, vai retornar da Terra, trazendo resultados de experimentos e alguns outros itens. Tá? Provavelmente nós não teremos a live da chegada, porque vai ser às 5 horas da manhã, mas eu faço um vídeo para a galera aí, mostrando como vai ser essa chegada, e até dando mais detalhes, que eu vou montar um vídeo editadozinho, dando maiores informações. Tá bom? Abraço a todo mundo aí, muito obrigado quem acompanhou. Tamo junto aí.